Okay, so general form. What does it mean to be a whole number here? It means that a is positive. The coefficient a is a positive. B and C, they can be negative. That's okay for B and C to be negative, but the a has to be positive. Okay? And you're not allowed any denominators for this format. Okay, because they're restricting you to whole numbers, so no fractions, and integers, no fractions, so no denominators, which you guys will probably like. The general form, while it's kind of not very useful in terms of building equations or drawing graphs, it's nice because there's no fractions. So we learn a skill. We learn a skill in this section that is actually useful in other algebraic situations. The skill here is multiply everything, multiply every term by the LCM. You recall the LCM from a couple units ago. It's the lowest common multiple. For the first one, because there's only one fraction, and I'm going to actually use, instead of m here, to help you remember, I'm just going to put this one instead. LCD, lowest common denominator. It's the same idea, but it might be easier for you to remember lowest common denominator. So for this first question, like, where is there a problem? We're not allowed to have fractions, so what's the problem? That 3 can't be there. It's a 3 in the denominator. That means divide 3. So what's the opposite of divide 3? Multiply 3. So if we want to multiply that guy by 3, but also maintain the equality, everything has to still be equal. So if you times that by 3, you got to times that by 3, and you got to times that by 3. Everything has to be tripled to maintain equality. So just think about that. You got a balanced beam, right? There's stuff over here, there's stuff over here. It's balanced. If I triple the amount of stuff on this side, how is it going to remain balanced? I would also have to triple whatever is on this side, or else it'll tip. It won't be equal anymore. Hopefully that makes sense. Whatever you do to one side, you do the other. You've probably heard that all your life, since like grade school. Okay, so what I like to do is I like to wrap a bracket times 3, wrap a bracket times 3. So on the left, you got 3y. I don't think there's any issues with that. But on the right, what do you have to do here? You have to distribute. So when the 3 scales this, the 3's will actually cancel. But I'll write it out for you to see how it works. So I just wrote the step out for you. The whole point of multiplying by 3 was to get rid of this 3. And when you have identical objects top and bottom, they will cancel for a placeholder 1. Because 3 divided by 3 is 1. 3 groups of 3 is 1. Okay, so what do we got here? We got, oh, what am I missing here? I feel like I screwed up here. What am I missing? The x. Yeah, the x is still in there. Okay, so we got 3y minus 2x plus 12. Does anybody have any questions about that? 3 goes in there, cancels that 3, you're just left with minus 2. 3 goes in there, times is by the 4, and you get 12. So if you look at the general form on the whiteboard, it's got to be equal to 0. So we have two options. Pick the 2x and the 12 up over and put it on this side, or pick up the 3y and put it on that side. Basically, you could have a 0 on the left, or you could have a 0 on the right. It's up to you. If you want to do it properly, the way they want it, you got to have a, which is the coefficient on the x, it's got to be positive. So take a look at the coefficient on the x. Is it positive? It's negative, right? So we're going to take the stuff on the right and bring it to the left. Good. So I'm just going to sneak the equal sign a bit over so I have room. So negative 2x on the right is positive 2x on the left. Then I'll put the 3y and then I'll put the 12. Why? No real reason, just convention. The convention is just to have the x, then the y, then the constant. It doesn't have to be that way. 3y was positive on the left. Oh, thank you very much, you guys. Jumping. Two mistakes in 5 minutes. Wow. Need more coffee. How are we doing with that? So the only thing that was new was this. Multiply every term by the LCD. So just find the denominators. Find the denominator. And get rid of it. That's all you gotta do. Find that denominator, get rid of it. So next one, where's the denominator? 5. I don't want 5 there. So what am I gonna do? Times everything by 5. This one's a little bit different though. So if I times the left by 5, it'll look like that. If I times the right by 5, it'll look like that. The left side you're probably familiar with. This is just distribution. So what's the left going to be like? 5y take away 5. Now the right hand side will cause some confusion. Do I times the 5 and the 3/5? Does the 5 go in the bracket? What do I do here? Just with the 3/5, yeah. Because once you figure out what this is, then you go inside. And the whole point of timesing by 5 was to get rid of that one, right? So only the 3 goes inside. And you end up with 3x plus 6. And you can see how easy it is to make mistakes. You watch me do it. I've been doing this for 15 years. And on part A, I made 2 easy mistakes quite like without even thinking. So be careful, take your time, stay organized. All right, so which way should we put all the terms? Remember, we want the thing on the x to be positive. Oh, it's already positive, right? This is a good thing. We want this one positive. So those two guys, get up and go. 5y, just look at him. Is he positive or negative? Positive on the left. So on the right, 5y is going to be, yeah, it's like, what do you call it? I'm forgetting the word. Alternate universe? Do you guys know my first name? Todd. So if I'm Todd on this side of the equality, on the other side, I'm Tad. You guys know Dr. Seuss? Tad and Todd? The 2 twins? No? So there's like Todd, that's like when I'm normal. Then there's Tad, that's when I'm like opposite. Just like 5y. Terrible analogy, right? Okay, I'll stop. Dot, actually. Yes, Todd is spelled with 2 D's, yeah. T-O-D-D. Alright, so I threw the -5 to the other side as a +5. Threw the +5y to the other side as a -5y. But you can also collect your like terms. 5 and 6 will make 11. How you guys feeling about this? A little bit easier than the stuff on the last day? So I will review last day's stuff next week. Okay? But doesn't mean we can just give up on things. We got to keep working hard. All right. So we're given an equation in the general form. First of all, what's A? 3. What's B? 2. And what's C? -18. Good. So you can identify coefficients. Now, in order to graph the line, looking at this, I see nothing. Nothing helps me. Nothing. So what I can use are the x and y intercepts. I'll use my pointer to show you where x-intercepts are. So what's the coordinate when you're finding an x-intercept? For y. What's the coordinate for y? Okay, so for the x-intercept, set y equal to 0, you get 3x plus 2 times 0 minus 18 equals 0. Well, what's 2 times nothing? Nothing. So then you get 3x take away 18 equals 0. I want somebody to solve this without doing any algebra. Just look at it. And don't yell it out yet. Got it? Just hold on to your answers. Any more hands? You got it? Without doing any algebra. Okay. Yell out the answer. It is 6. Can you guys see why it's 6? 3 times some number, take away 18 gives you nothing. Well, 18 is a multiple of 3, right? So this is going to work out perfectly. Okay. If you want to just do the algebra, 18 has to go to the other side, correct? Right now, there's nothing on the right side. Nothing. So 18 has to go over there. Which form will it take? Tad or Todd? Oh my gosh. Now what? Now what, Zach? Divide by... So what does that mean? Why do I have a solution here that says x is 6? It tells you that x is 6 when the y is... Plot that point. It's right here. When the x is 6, the y is 0. Now do the same thing for the y-intercept. Okay, for the y-intercept, what would you have to set to 0? Yeah, because now for y-intercepts, this is where y-intercepts live. When the x is 0. So we set x equal to 0. So 3 times 0 plus 2y minus 18 equals 0. What's 3 times nothing? So 2y take away 18 equals 0. Without doing any algebra, what's the value of y? Now we're getting there. Yeah. Okay. Take the 18 to the other side. Divide by 2. So what does this mean? It means when x is 0, the y is 9. So it's not even on our screen. That's great. Now what do you do with those 2 points? You draw a little bit of a thinner line. I missed. And then what do we do? What do we put on the ends? Oh, you guys making me happy here. Okay? So we only have 2 more to go. So the lesson will be over in about 10 minutes. You're going to have more time than usual to do homework. You're going to get your homework done. Then I'm going to give you a quiz on this stuff. And then you're going to have a good weekend. Okay? Your only homework I want you to think about is the stuff I went over yesterday. I want you to try and practice the stuff we did yesterday. Those of you that already mastered it, there's a number of you in here, a good handful. Take it easy this weekend. Focus on other stuff. But for everyone else who struggled with that stuff yesterday, please take those home and practice. And you can redo the same questions. You got the solution there that I did. Just copy down the question on a separate paper, try it, and then look at my solution if you need help. Okay? Scaffold yourself to success. No, it's not, Zach. It's practice. Oh, look at this question here. We had to do something like this in yesterday's homework. How do you find the slope of an equation? Or how do you find the slope of a line when it's written in an equation? Which equation does it have to be in? Yeah, and then you just have to identify, right? So I'm going to put a huge star on this question because I think it's very valuable. There's my huge star. And I want you to just jot down the notes. To find slope from an equation, isolate y. So you have this format. So what does it mean to isolate y? You just do algebra. Right now, you look at that y. Is it isolated? No, he's got a guy to the left, he's got a guy to the right. He looks left, he looks right. Is he by himself? Is he isolated? No. If you look at this equation, is the y isolated? Yeah, he's got nobody around him on that side. So here's your choices. Take 3x and 16 to the other side, or just move the 2y. Which one's easier? Move one thing or move two things? The other thing is, if you leave the 2y on this side, what do you have to remember to leave? The negative. And then on the next step, you're going to have to divide by a negative. You're going to have to remember to switch sign. It's actually the most efficient to just move the 2y. So now what's left? You have a 3x, you have a minus 16, and you have 2y. Because what's minus 2y plus 2y? What's minus 2y plus 2y? That is just 0, pair, right? So what you do to the left, you do to the right. So is y by itself closer, but not quite? What's the coefficient on the y? On this board? 1. What's this coefficient? How do I make 2 look like 1? Divide by 2. And you always have that pattern. You divide by the same number in front of the coefficient. Now what you do to the right, you got to do to the... So do I only divide the 16 by 2? Or you also divide this one by 2? Good. Now 16 and 2, they work together very nicely, but 3 doesn't work with 2 nicely. Do you go to a decimal? No. Definitely leave it as a fraction. So 3x over 2 minus 8 equals y. So now you can identify the slope. The slope is the coefficient. It can be a decimal, it's just not as helpful, because when it's written as 3 over 2, you know that the line will be 2 to the right and 3 up. And the y-intercept is negative 8. Okay, let's do the one underneath, and then you guys are good to go. Send the 5x and the 12, or just send the 2y? What do I divide by? So 5 halves x plus 6. Is it easy to identify the m? Is it easy to identify the y-intercept? So when you go to graph this, you put on 6, 2 to the right, and then 5 up. And there's your graph. Okay, you got homework down at the bottom. There's 5 questions, so not a lot. And then once those are done, I'll give you the quiz in about 15 minutes.